Above us, a celestial tapestry unfolds every night, a cosmic dance of stars, planets, and distant galaxies. Among these celestial wonders, one particular object has captivated the human imagination for millennia: Mars, the red planet. Its fiery hue, visible even to the naked eye, has sparked countless myths and legends, painting tales of war, passion, and the unknown. What is it about Mars that draws us in, that ignites our curiosity and fuels our dreams of reaching beyond our pale blue dot? Perhaps it is the allure of the unknown, the siren song of a world yet to be fully understood. Or maybe it is the promise of adventure, the chance to set foot on virgin soil and leave our mark on a new world. Whatever the reason, Mars beckons us with the irresistible allure of discovery. Its barren landscapes, sculpted by eons of geological activity, hold secrets waiting to be unearthed. Its thin atmosphere, once thicker and capable of supporting liquid water, whispers tales of a lost past, a time when Mars may have been a vibrant, life-sustaining world like our own. Our journey to understand Mars began in earnest in the mid-20th century with the dawn of the space age. The Soviet Union launched the first spacecraft to Mars, Mars 1, in 1962, followed closely by NASA's Mariner 4 mission in 1965. These early missions, though limited in scope, provided our first tantalizing glimpses of the Martian surface, revealing a cratered and seemingly lifeless world. But as our technology advanced, so too did our understanding of the Red Planet. The Viking missions in the 1970s, the first to land successfully on Mars, sent back stunning images of the Martian landscape and conducted the first experiments searching for signs of life. To truly grasp the allure and mystique of Mars, we must first journey across the vast expanse of our solar system and familiarize ourselves with our celestial neighbor. Orbiting the Sun at an average distance of 142 million miles, Mars claims the fourth position in our planetary lineup, residing just beyond our own Earth. While it may seem like an unfathomable distance separating us from this alien world, cosmically speaking, Mars is just a stone's throw away. In the grand scheme of the cosmos, where distances are measured in light years, the gulf between Earth and Mars shrinks to a mere hop, skip, and a jump. This proximity, combined with Mars's intriguing characteristics, has made it a prime target for exploration and fueled our dreams of one day sending humans to walk upon its dusty surface. Unlike the scorching inferno of Venus or the gas giants beyond, Mars presents us with a tantalizingly familiar yet alien world, a place where the boundaries between science fiction and reality blur. Section 2. The Red Planet's vital statistics. In the realm of planetary dimensions, Mars tips the cosmic scales as a relatively small world dwarfed by the behemoths of our solar system like Jupiter and Saturn. With a diameter of approximately 4,220 miles, Mars is just over half the size of Earth, making it more akin to our own planet than its gargantuan siblings. This diminutive stature translates to a weaker gravitational pull compared to our home planet. On Mars, you'd experience a mere 38% of Earth's gravity, meaning you could leap tall rocks in a single bound and effortlessly lift objects that would normally leave you winded. Imagine the possibilities for athletic feats and the sheer joy of experiencing a lighter side of gravity. This difference in gravity has played a significant role in shaping the Martian landscape, influencing everything from the height of its mountains to the thickness of its atmosphere. The weaker gravitational pull means that Mars has had a harder time holding onto its atmosphere over billions of years, contributing to its present-day thin and tenuous air. But don't let its smaller size fool you. Mars is a world of dramatic contrasts and awe-inspiring features, from towering volcanoes that dwarf Mount Everest to canyons so grand they make the Grand Canyon look like a mere crack in the sidewalk. Mars is a testament to the power of geological forces at play. Section 3. A Day and a Year on Mars. If you're planning a future Martian vacation, you'll be pleased to know that a day on Mars, known as a sol, is remarkably similar in length to an Earth day. A single rotation on its axis takes Mars approximately 24.6 hours, meaning you wouldn't have to adjust your sleep schedule too drastically. Imagine waking up to a Martian sunrise, the reddish hue of the sky casting long shadows across the desolate landscape, and settling in for a night's rest as the two Martian moons, Phobos and Deimos, dance across the star-studded sky. A Martian day, while slightly longer than our own, would hold a familiar rhythm. However, when it comes to the length of a Martian year, things get a bit more exotic. Due to its greater distance from the Sun and slower orbital speed, a year on Mars stretches out to a leisurely 687 Earth days, almost twice as long as our own earthly orbit. This means that seasons on Mars are significantly longer, with each season spanning nearly 6 Earth months. Imagine a Martian summer that stretches on for what seems like an eternity, or a winter that grips the planet in its icy embrace for an extended period. The concept of time takes on a whole new meaning on the red planet, offering a unique perspective on the passage of time in our solar system. Section 1. A Tapestry of Extreme. The Martian surface is a testament to nature's capacity for both grandeur and subtlety, a canvas painted with broad strokes of cosmic drama and intricate details etched by eons of geological activity. Unlike the familiar, life-sustaining embrace of Earth, Mars presents a landscape of stark contrasts, a world of towering volcanoes that pierce the heavens, canyons so vast they dwarf our own terrestrial wonders, and windswept plains that stretch towards the horizon like an endless rusty sea. Imagine standing on the edge of a Martian cliff, the thin, cold air whipping at your spacesuit, and gazing out upon a vista that seems both alien and strangely familiar. The sky above, a pale salmon pink during the day, transitions to a deep indigo as the sun dips below the horizon, casting long, eerie shadows across the desolate landscape. The silence is profound, broken only by the whisper of the wind as it sculpts the dunes and whistles through canyons, a constant reminder of the forces that have shaped this world for billions of years. Mars is a world of extremes, where temperatures can plummet to hundreds of degrees below freezing at night, and soar to a balmy spring day at the equator, only to plunge again as the sun sets. It's a place where dust storms can engulf the entire planet, blotting out the sun for months on end, and where ancient riverbeds, now dry and cracked, hint at a time when liquid water flowed freely across its surface. In this chapter, we'll embark on a journey across the Martian landscape, exploring its most dramatic features and unraveling the geological processes that have shaped this alien world. From the summit of Olympus Mons, the tallest volcano in our solar system, to the depths of Valles Marineris, a canyon system so grand it boggles the mind, we'll witness the awesome power of nature on a planetary scale. Section 2. Olympus Mons, the giant of the solar system. Dominating the Martian landscape like a celestial shield volcano, Olympus Mons stands as a testament to the raw, untamed power that once surged through the red planet's veins. This colossal volcano, the largest in our solar system, stretches an astounding 370 miles in diameter, its base easily encompassing the entire state of Arizona. Its summit, piercing the thin Martian atmosphere at a height of 16 miles, reaches more than twice the elevation of Mount Everest, Earth's highest peak. Imagine standing at the foot of this behemoth, its slopes rising gradually at first, then steepening dramatically as they ascend towards the heavens. The sheer scale of Olympus Mons is difficult to comprehend, its summit lost in a perpetual haze of dust and ice crystals. To circumnavigate its base would be akin to hiking the entire circumference of Earth's moon, a testament to its colossal proportions. Olympus Mons is a shield volcano, formed by the slow and steady eruption of lava flows over millions of years. Unlike the explosive eruptions that characterize some terrestrial volcanoes, the lava flows on Mars were less viscous, spreading out over vast distances and gradually building up the volcano's gently sloping flanks. The result is a volcanic structure of unparalleled size and grandeur, a monument to the immense forces that once shaped the Martian surface. The sheer size of Olympus Mons, along with its relatively flat topography, has led scientists to speculate that it may have once been an island, surrounded by an ancient Martian ocean. As lava flows continued to erupt, the volcano gradually rose above the waterline, its summit eventually piercing the Martian sky. While this remains a theory, it's a tantalizing glimpse into the possibility of a very different Mars in the distant past. Section 3, Valles Marineris, a Grand Canyon on Mars. If Olympus Mons represents the verticality of the Martian landscape, then Valles Marineris, the grandest canyon system in our solar system, embodies its horizontal expanse. Stretching over 2,500 miles across the Martian surface, this immense scar dwarfs Earth's Grand Canyon in both length and depth. To put its size into perspective, imagine a canyon that stretches from New York City to Los Angeles, its depths plunging over 4 miles below the surrounding plains. The formation of Valles Marineris is thought to be linked to the Tharsis region, a vast volcanic plateau that lies to the west of the canyon system. As the Tharsis volcanoes erupted and grew, the weight of the accumulating lava is believed to have caused the Martian crust to stretch and fracture, eventually leading to the colossal rift that is Valles Marineris. Exploring Valles Marineris is a journey through time and geological upheaval. Its walls, towering miles above the canyon floor, expose layers of rock that date back billions of years, providing a glimpse into the red planet's ancient past. Within its depths, landslides have carved massive scars into the canyon walls, testament to the ongoing forces that continue to shape this alien world. Evidence suggests that Valles Marineris may have once been a much wetter place than it is today. Channels carved by flowing water have been discovered within the canyon system, hinting at a time when rivers or even glaciers may have flowed through its depths. These discoveries fuel the imagination, painting a picture of a Mars that was once a far more dynamic and perhaps even life-sustaining world. Section 4. A surface shaped by time. The Martian surface, a tapestry woven from volcanic rock, wind-blown dust, and the scars of ancient impacts, stands as a testament to the relentless power of time and the forces that have shaped this alien world over billions of years. Unlike Earth, with its active geology and life-sustaining biosphere that constantly reshape its surface, Mars has preserved a record of its past in its craters, canyons, and plains. Imagine yourself standing on the Martian surface, the rusty red dust crunching beneath your boots. As you gaze across the landscape, you're surrounded by evidence of a tumultuous past. Impact craters, some small and fresh, others vast and eroded by eons of wind and dust storms, dot the landscape like celestial battle scars, reminders of the violent bombardment that characterized the early solar system. The Martian wind, thin though it may be, has played a significant role in shaping the planet's surface. Over millennia, it has sculpted towering dunes, carved intricate patterns into the rock, and transported dust across vast distances, creating a world of subtle beauty and stark contrasts. This wind-driven erosion has both revealed and obscured the planet's history, exposing ancient layers of rock in some areas while burying others beneath a thick blanket of dust. As we explore the Martian surface in greater detail, we'll uncover evidence of a more dynamic past, a time when liquid water flowed freely, carving channels, forming lakes, and perhaps even supporting the emergence of life. The search for signs of this watery past and the potential for life that it may have harbored drives our exploration of Mars and fuels our desire to unravel the secrets of this enigmatic world. As we delve deeper into the mysteries of Mars, we encounter one of the most tantalizing questions in planetary science. Did liquid water once flow across the surface of this now arid world? The answer, it turns out, is a resounding yes. While the Mars of today is a cold, dry desert, a wealth of evidence points to a time when rivers flowed, lakes shimmered, and perhaps even oceans lapped at its shores. This ancient watery past holds the key to understanding the planet's evolution and the potential for life beyond Earth. The evidence for a watery past on Mars comes from a variety of sources, from the planet's geology to the chemical signatures detected by our robotic explorers. The most compelling clues are the telltale signs etched into the Martian landscape. Vast networks of valleys, ancient lake beds, and the unmistakable fingerprints of erosion by flowing water. These features, preserved for billions of years in the planet's dry, cold embrace, paint a picture of a Mars that was once a far more dynamic and potentially habitable world. The idea of a watery Mars is not merely a product of scientific speculation. It's supported by a growing body of evidence gathered over decades of robotic exploration. From the first grainy images sent back by the Viking orbiters in the 1970s to the high-resolution data collected by modern missions like Mars Reconnaissance, Orbiter and Curiosity, the evidence has only grown stronger. The more we learn about Mars, the more we realize that its history is intimately intertwined with the presence of liquid water. The implications of a watery past on Mars are profound. On Earth, where there's water, there's life. While we haven't yet found definitive proof of past or present life on Mars, the presence of liquid water in its ancient past raises the tantalizing possibility that life may have arisen there independently. The search for signs of this ancient life, whether in the form of fossils or chemical biosignatures, is one of the most compelling drivers of Mars exploration today. Imagine soaring above the Martian surface, the rusty red plains stretching out before you like an endless, windswept desert. As you peer down from your vantage point, you begin to notice subtle patterns etched into the landscape, features that speak of a time when water flowed freely across this alien world. These features, sculpted by the erosive power of ancient rivers, lakes, and perhaps even oceans, provide a window into Mars' watery past. One of the most striking pieces of evidence is the presence of vast networks of valleys, some stretching for thousands of miles across the Martian surface. These valleys, with their branching tributaries and sinuous channels, bear an uncanny resemblance to river systems on Earth, suggesting that they were carved by the gradual erosion of flowing water over millions, if not billions, of years. These ancient Martian rivers would have been a far cry from the raging torrents we associate with rivers on Earth. In addition to valley networks, scientists have also identified numerous examples of ancient lake beds on Mars. These depressions, some of which are thought to have once held vast quantities of water, often exhibit telltale signs of past shorelines, deltas and sedimentary deposits, all pointing to a time when liquid water pooled on the Martian surface. These ancient lakes would have been prime locations for the development of life, offering a stable environment and the essential ingredients for life as we know it. The Martian landscape is also dotted with craters, many of which show evidence of erosion by flowing water. These craters, formed by impacts from asteroids and comets, often feature channels carved into their rims and walls, suggesting that water once flowed into and out of these depressions. In some cases, scientists have even found evidence of ancient glaciers within these craters, remnants of a time when Mars was a much colder and icier place. To further unravel the story of Mars's watery past, scientists have deployed a fleet of robotic explorers to the Red Planet, each equipped with instruments capable of detecting and analyzing the chemical signatures of water. These rovers and landers, acting as our eyes and ears on the Martian surface, have provided invaluable insights into the history and distribution of water on Mars. One of the key findings from these missions has been the detection of hydrated minerals in Martian rocks and soil. These minerals, which incorporate water molecules into their crystalline structure, provide strong evidence that liquid water once interacted with the Martian surface. The presence of these minerals has been confirmed in numerous locations across Mars, from the plains of Meridiani Planum, explored by the Opportunity rover, to the foothills of Mount Sharp, currently being investigated by the Curiosity rover. Another line of evidence comes from the study of Martian meteorites, fragments of rock blasted off the planet's surface by ancient impacts that have landed on Earth. These meteorites, carefully collected and analyzed in laboratories around the world, have provided further confirmation of Mars' watery past. Some of these meteorites contain minerals that could only have formed in the presence of liquid water, while others exhibit chemical signatures consistent with exposure to a watery environment. The search for evidence of past water on Mars is not just about piecing together the planet's history, it's also about understanding the potential for life beyond Earth. On Earth, wherever we find liquid water, we find life. While we haven't yet found definitive proof of life on Mars, the presence of liquid water in its past suggests that the Red Planet may have once been a habitable world, capable of supporting microbial life, if not more complex organisms. The evidence for a watery past on Mars has led scientists to speculate about the possibility that life may have once existed on this now arid world. If liquid water flowed on the Martian surface for millions or even billions of years, it's conceivable that life in some form may have emerged and thrived in these ancient environments. The search for signs of this past life, whether in the form of fossilized microbes or chemical biosignatures, is one of the most exciting and challenging frontiers in astrobiology. One of the most promising places to look for signs of ancient life is in the sedimentary deposits left behind by ancient lakes and rivers. On Earth, these types of environments are teeming with life, and the sediments that accumulate over time often preserve the remains of organisms, providing a fossil record of past ecosystems. If similar environments existed on Mars in the past, it's possible that they too may have harbored life. To search for signs of ancient life, scientists are employing a variety of techniques, both on the Martian surface and in laboratories here on Earth. Rovers like Curiosity and Perseverance are equipped with instruments capable of analyzing the chemical composition of Martian rocks and soil, searching for organic molecules and other biosignatures that might indicate the presence of past life. The search for ancient life on Mars is a daunting task, but it's a challenge that scientists are eager to tackle. The discovery of even the simplest fossilized microbe would be a monumental achievement, revolutionizing our understanding of life in the universe and fundamentally changing our place within it. The Red Planet, once a symbol of barrenness and desolation, has transformed into a beacon of hope, a place where the dream of finding life beyond Earth may one day become a reality. The tantalizing evidence of a watery past on Mars has ignited a profound question. If liquid water once flowed freely across its surface, could life have emerged there as well? This question, a cornerstone of astrobiology, drives our exploration of the red planet and fuels our imaginations as we seek to unravel the mysteries of life's origins and its potential existence beyond Earth. The ingredients necessary for life as we know it, liquid water, organic molecules, and the source of energy, are believed to have been present on early Mars. Billions of years ago, when the planet was warmer and wetter, conditions may have been favorable for the emergence of microbial life, perhaps in the depths of ancient lakes or within the porous rocks beneath the surface. While the surface of Mars today is a harsh and unforgiving environment, bombarded by radiation and scoured by the solar wind, it's possible that life, once established, could have found refuge underground, where conditions may be more stable and protected. Extremophiles on Earth, organisms that thrive in environments once thought uninhabitable, provide compelling evidence for life's tenacity and its ability to adapt to seemingly insurmountable challenges. The discovery of methane in the Martian atmosphere has further fueled speculation about the possibility of extant life on Mars. Methane, a gas often associated with biological activity, could be a signature of microbial life lurking beneath the surface, releasing this telltale gas into the thin Martian air. While the source of this methane remains a subject of debate, its presence adds another layer of intrigue to the question of life on Mars. Unveiling the secrets of Mars's past and searching for signs of ancient life requires a multi-pronged approach. A symphony of robotic explorers equipped with sophisticated instruments capable of detecting the faintest whispers of biology. These missions, meticulously planned and executed, are pushing the boundaries of our technological prowess and providing a glimpse into the hidden history of our celestial neighbor. Rovers like Curiosity and Perseverance are not merely exploring the Martian surface. They're acting as robotic geologists and astrobiologists, meticulously analyzing rocks, soil, and the atmosphere for clues about the planet's past habitability and the potential for life. These mobile laboratories, equipped with drills, lasers, and analytical instruments, are capable of identifying the chemical building blocks of life and detecting the subtle signatures of biological processes. One of the key objectives of these missions is to search for organic molecules, the complex carbon-based compounds that are essential for life as we know it. The discovery of organic molecules on Mars wouldn't necessarily prove the existence of past life, as these molecules can also be created through abiotic processes. But it would be a significant finding, suggesting that the raw materials for life were present on early Mars. In addition to searching for organic molecules, scientists are also looking for other biosignatures, such as mineral deposits that could have been formed by biological activity or isotopic ratios that deviate from those expected in non-biological systems. These subtle clues, like whispers from the past, could provide the evidence we need to confirm that life once existed on Mars. The quest to determine whether life ever existed on Mars is a testament to the indomitable spirit of human curiosity and our relentless pursuit of knowledge. It's a journey driven by the desire to understand our place in the cosmos and to answer one of the most profound questions ever asked: are we alone? The challenges of exploring Mars and searching for signs of ancient life are immense. The distances are vast, the environment is harsh, and the evidence we seek is likely to be subtle and difficult to interpret. Yet despite these obstacles, we persevere, driven by the belief that the rewards of discovery far outweigh the risks and the costs. The search for life on Mars is a global endeavor, involving scientists and engineers from around the world, all working together to unravel the secrets of our celestial neighbor. It's a testament to the power of international collaboration and our shared desire to push the boundaries of human knowledge. Whether we find definitive proof of past life on Mars or not, the journey itself is transforming our understanding of the red planet and our place within the cosmos. With each mission, we learn more about the history of Mars, the conditions that allowed liquid water to exist on its surface, and the potential for life to emerge in environments that differ vastly from our own. The exploration of Mars is a journey of discovery, a testament to the power of human ingenuity and a source of inspiration for generations to come. In stark contrast to the life-sustaining embrace of Earth's atmosphere, Mars finds itself cloaked in a thin, ethereal veil of air, a mere whisper compared to the dense blanket that envelops our own planet. This tenuous atmosphere, a shadow of its former self, exerts a surface pressure roughly 1% that of Earth's at sea level, akin to the pressure found at an altitude of about 22 miles above Earth's surface. Stepping onto the Martian surface, you'd experience a sensation akin to standing atop a towering mountain, the air thin and the sky a pale dusty pink. The composition of this wispy Martian air is also markedly different from our own. While Earth's atmosphere is a vibrant mix of nitrogen, oxygen and trace gases, Mars' atmosphere is dominated by carbon dioxide, comprising roughly 96% of its volume. This abundance of carbon dioxide, a greenhouse gas, might lead one to expect a warmer climate, but the thinness of the atmosphere negates any significant warming effect. Instead, Mars experiences dramatic temperature swings, with frigid nights plunging hundreds of degrees below freezing, and relatively mild days rarely exceeding the freezing point of water. The thinness of Mars's atmosphere has profound implications for the planet's habitability. With little to shield it from the harsh realities of space, the Martian surface is exposed to a relentless barrage of solar radiation, harmful ultraviolet rays that would make life as we know it impossible without significant protection. Additionally, the lack of a substantial atmosphere prevents liquid water from existing on the surface for any extended period. Any water that does venture out from beneath the surface, perhaps seeping from underground reservoirs, would quickly sublimate, turning directly from ice to vapor in the thin, dry air. Understanding the history and evolution of Mars's atmosphere is crucial to unraveling the planet's past and its potential for hosting life. Scientists believe that Mars once possessed a much thicker, warmer atmosphere, perhaps even capable of supporting liquid water on its surface. However, over billions of years, this atmosphere was gradually stripped away by the solar wind, leaving behind the tenuous veil we see today. The loss of this atmosphere, a consequence of the planet's weak magnetic field, transformed Mars from a potentially habitable world into the cold, dry desert we see today. While the Martian atmosphere may be thin, it's far from static. Driven by the uneven heating of the planet's surface and the sublimation of its polar ice caps, the Martian winds can whip up into a frenzy, creating dust storms that dwarf anything seen on Earth. These storms, ranging in scale from local dust devils to planet-encircling behemoths, are a testament to the power of atmospheric circulation, even in the absence of a dense atmosphere. Imagine standing on the Martian surface, the thin air tugging at your spacesuit as a wall of dust approaches, blotting out the already dim sun and turning the sky a menacing yellow-brown. The wind howls around you, carrying fine particles of dust that sting exposed skin and infiltrate every nook and cranny of your equipment. These dust storms, while fascinating to observe from afar, pose a significant challenge to robotic explorers, coating solar panels, disrupting communications, and potentially damaging sensitive instruments. Dust devils, smaller but no less impressive, are a common sight on Mars. These swirling vortices of dust, often reaching hundreds of feet in height, are formed by the rising of warm air from the sun-baked surface, creating miniature tornadoes that dance across the Martian plains. While these dust devils pose little threat to robotic explorers, they serve as a reminder that even in a thin atmosphere, dynamic weather phenomena can occur. The Martian winds, while often destructive, also play a crucial role in shaping the planet's surface. Over eons, they have carved intricate patterns into the landscape, sculpting towering dunes, eroding canyons, and transporting dust across vast distances. This wind-driven erosion has both revealed and obscured the planet's history, exposing ancient layers of rock in some areas, while burying others beneath a thick blanket of dust. The Mars of today, with its frigid temperatures, thin atmosphere and desolate landscapes, stands in stark contrast to the planet envisioned by scientists studying its ancient past. Billions of years ago, Mars is believed to have been a much warmer and wetter world, perhaps even harboring oceans and a thicker, more protective atmosphere. So what happened? What transformed this once potentially habitable planet into the cold, dry desert we see today? The key to understanding Mars's dramatic climate transformation lies in the planet's magnetic field, or rather, the lack thereof. Earth's magnetic field, generated by the churning of molten iron in its core, acts as a protective shield, deflecting the solar wind, a stream of charged particles constantly emanating from the sun. This magnetic shield is crucial for maintaining Earth's atmosphere, preventing it from being stripped away by the relentless onslaught of solar particles. Mars, unfortunately, wasn't so lucky. Early in its history, Mars likely possessed a global magnetic field similar to Earth's. However, over time, this magnetic field weakened significantly, perhaps due to the cooling of the planet's core. As the magnetic field waned, the solar wind gained a foothold, gradually stripping away Mars's atmosphere over billions of years. The loss of Mars's atmosphere had a cascading effect on the planet's climate. With less atmosphere to trap heat, temperatures plummeted, and the once flowing rivers and lakes froze solid or evaporated into space. The surface exposed to the harsh radiation of the sun became increasingly inhospitable, transforming Mars into the cold, dry world we see today. This dramatic climate transformation serves as a stark reminder of the delicate balance that governs planetary habitability and the importance of a protective magnetic field in maintaining a life-sustaining environment. The dream of reaching Mars, once confined to the pages of science fiction and the imaginations of visionaries, took its first tentative steps toward reality in the latter half of the 20th century. The space age, ignited by the launch of Sputnik and fueled by the spirit of Cold War competition, ushered in an era of unprecedented technological advancement, paving the way for humanity's first forays beyond Earth's gravitational embrace. Mars, the enigmatic red planet, beckoned as a tantalizing target, its secrets waiting to be unlocked by the ingenuity of our species. The early missions to Mars were fraught with challenges, both technical and financial. Launching a spacecraft across millions of miles of interplanetary space, ensuring its safe arrival in the Martian gravitational well, and successfully landing on a planet with a thin atmosphere and a notoriously unforgiving surface, pushed the limits of engineering and human ingenuity. Yet, despite the setbacks and the disappointments, the drive to explore Mars persisted, fueled by the insatiable thirst for knowledge and the desire to unravel the mysteries of our celestial neighbor. The first successful flyby of Mars, achieved by NASA's Mariner 4 spacecraft in 1965, provided our first tantalizing glimpse of the Martian surface, albeit a somewhat disappointing one. The images beamed back to Earth revealed a cratered, seemingly barren world, a far cry from the lush, canal-covered planet envisioned by some early astronomers. Nevertheless, Mariner 4's historic flyby marked a turning point in our exploration of Mars, proving that reaching this distant world was indeed possible and setting the stage for more ambitious missions to come. The Viking missions, launched in 1975, represented a quantum leap forward in our exploration of Mars. Comprising two identical spacecraft, each consisting of an orbiter and a lander, Viking 1 and Viking 2 were tasked with not only photographing the Martian surface in unprecedented detail, but also conducting the first experiments designed to search for signs of life. The Viking landers touched down on the Martian surface in July and September of 1976, marking a historic milestone in human exploration, the first successful soft landings on another planet. In the annals of space exploration, few missions have captured the public's imagination and inspired as much awe and wonder as the twin Mars exploration rovers, Spirit and Opportunity. Launched in the summer of 2003, these robotic explorers embarked on what was initially planned as a 90-day mission to search for evidence of past water on Mars. Little did anyone know that these tenacious rovers would far exceed their planned lifetimes, racking up years of groundbreaking discoveries and becoming cultural icons in the process. Spirit and Opportunity were more than just sophisticated machines. They were emissaries of human curiosity, equipped with the tools and the tenacity to explore the Martian surface in unprecedented detail. Their mission, to seek out and analyze rocks and soils that might hold clues to the red planet's watery past, was a testament to our species' unyielding desire to understand our place in the cosmos and to search for signs of life beyond Earth. Landing on opposite sides of Mars in January 2004, Spirit and Opportunity set out on their respective journeys of exploration, their every move chronicled by an eager public back on Earth. Spirit, touching down in Gusev Crater, a site thought to have once held a vast lake, spent its time exploring a variety of geological formations, including hills, plains, and even a dust devil. Opportunity, landing on Meridiani Planum, a region rich in hematite, a mineral often associated with water, made a groundbreaking discovery almost immediately upon its arrival. The discovery of blueberries, small spherical concretions rich in hematite, provided compelling evidence that liquid water had once flowed on the Martian surface. This finding, along with the discovery of other telltale geological formations, such as cross-bedding patterns in rocks, confirmed that Mars had once been a much warmer and wetter world than it is today, a place where life, at least in microbial form, could have potentially existed. And building upon the legacy of its predecessors, the Curiosity rover, launched in November 2011, marked a new era in Mars exploration, equipped with a suite of sophisticated instruments designed to delve deeper into the red planet's past and its potential for hosting life. Curiosity, larger and more capable than any rover that had come before it, was tasked with answering a fundamental question. Did Mars ever have the right environmental conditions to support microbial life? Landing in Gale Crater in August 2012, a site chosen for its diverse geology and its potential for preserving evidence of past habitability, Curiosity embarked on a mission of unprecedented scope and ambition. Its primary target, Mount Sharp, a towering peak rising from the center of the crater, promised to be a geological time capsule, its layers of sedimentary rock holding clues to billions of years of Martian history. Curiosity's mission went beyond simply detecting the presence of past water. It was designed to search for the chemical building blocks of life, such as organic molecules, and to investigate the environmental conditions that might have been conducive to life's emergence. To accomplish these goals, Curiosity was outfitted with a suite of 10 science instruments, including a laser-induced breakdown spectrometer capable of analyzing the composition of rocks and soils from a distance, a drill for collecting rock samples, and a sophisticated onboard laboratory for analyzing these samples in detail. Curiosity's findings have been nothing short of groundbreaking, revolutionizing our understanding of Mars and its potential for hosting life. The rover has detected organic molecules in Martian soil, confirming the presence of the building blocks of life on the red planet. It has found evidence of ancient lakes and rivers, suggesting that liquid water once flowed freely on the Martian surface, and it has analyzed the Martian atmosphere in unprecedented detail, providing insights into its evolution and the processes that led to its current thin and tenuous state. The latest chapter in humanity's ongoing saga of Mars exploration began with the arrival of the Perseverance rover and the Ingenuity helicopter in February 2021. These two robotic explorers, representing the cutting edge of space technology, have embarked on a mission that promises to redefine our understanding of the red planet and its potential for hosting life, both past and present. Perseverance, the largest and most sophisticated rover ever sent to Mars, has inherited the mantle of its predecessors, tasked with searching for signs of ancient life and paving the way for future human exploration. But unlike previous missions, Perseverance is not just exploring the Martian surface, it's collecting and caching rock and soil samples that will eventually be returned to Earth for detailed analysis, a feat that would mark a historic first in interplanetary sample return. Landing in Jezero Crater, a site thought to have once held a vast lake and a prime location for preserving evidence of past life, Perseverance has already begun its ambitious mission of exploration and sample collection. Equipped with a suite of advanced instruments, including a ground-penetrating radar for probing beneath the surface, a device for producing oxygen from the Martian atmosphere, and a sophisticated system for collecting and caching rock cores, Perseverance is poised to make groundbreaking discoveries that could rewrite our understanding of the red planet. Accompanying Perseverance on its journey is Ingenuity, a small solar-powered helicopter that has made history as the first aircraft to achieve controlled, powered flight on another planet. Ingenuity's mission, a testament to human ingenuity and the boundless possibilities of space exploration, is to demonstrate the feasibility of aerial exploration in the thin Martian atmosphere, scouting out potential targets for Perseverance, and providing a unique perspective on the Martian landscape. The dream of sending humans to Mars, once relegated to the realm of science fiction, has steadily inched its way into the realm of possibility, fueled by advancements in rocketry, life support systems, and our insatiable thirst for exploration. No longer a distant fantasy, the prospect of human footprints on Martian soil has become a tangible goal, a testament to the audacity of human ambition and our unwavering belief in pushing the boundaries of what's possible. Government agencies like NASA, with its Artemis program laying the groundwork for a sustained human presence on the Moon, and private companies like SpaceX, driven by the visionary leadership of Elon Musk and his audacious plans for a multi-planetary future, are actively developing the technologies and infrastructure necessary to make this dream a reality. Imagine a future not so distant, where sleek spacecraft powered by cutting-edge propulsion systems embark on daring journeys across the gulf of interplanetary space, carrying with them the hopes and dreams of a species determined to extend its reach beyond its home planet. Imagine the anticipation, the trepidation, and the sheer awe of those first pioneers as they descend through the thin Martian atmosphere, their spacecraft kicking up a plume of reddish dust as they touch down on a world that has captivated the human imagination for centuries. The first human missions to Mars will be monumental achievements, marking a pivotal moment in human history and ushering in a new era of exploration and discovery. These missions, fraught with challenges and uncertainties, will test the limits of human endurance, ingenuity, and our ability to adapt to the harsh realities of life beyond Earth. but the rewards, both scientific and inspirational, will be immeasurable, pushing the boundaries of human knowledge and igniting the imaginations of generations to come. The journey to Mars and the establishment of a sustained human presence on the Red Planet will be one of the most ambitious and challenging undertakings in human history, pushing the limits of our technological prowess, our physiological resilience, and our capacity for collaboration and innovation. The challenges are legion, each one a formidable hurdle to overcome in our quest to become a multi-planetary species. The journey itself, a months-long odyssey through the vastness of interplanetary space, will expose astronauts to a myriad of hazards, from the debilitating effects of microgravity and cosmic radiation to the psychological stresses of confinement and isolation. Developing spacecraft capable of shielding astronauts from these hazards, providing artificial gravity and maintaining a healthy and stimulating environment during the long journey will be paramount to the success of any human mission to Mars. Landing on Mars with its thin atmosphere and unforgiving terrain will be no less perilous. Developing landing systems capable of safely delivering large payloads, including habitats, rovers, and supplies to the Martian surface will be a critical technological hurdle. Once on the surface, the challenges only multiply. The thin atmosphere provides little protection from solar radiation or micrometeoroids, necessitating the construction of robust habitats capable of withstanding the harsh Martian environment. Living on Mars, even for a short duration, will require a level of self-sufficiency and resourcefulness never before attempted. Extracting water ice from the Martian soil, generating breathable air, and growing food in hydroponic farms will be essential for survival. Developing closed-loop life support systems capable of recycling waste products and minimizing reliance on Earth-based resupply missions will be crucial for establishing a sustainable human presence on the Red Planet. Despite the formidable challenges, the dream of establishing a permanent human presence on Mars continues to inspire and motivate, driving innovation and pushing the boundaries of what's possible. The rewards of such an endeavor extend far beyond the scientific discoveries that await us on the Red Planet. They encompass the very essence of what it means to be human, our innate curiosity, our drive to explore, and our desire to leave our mark on the cosmos. Imagine a future where Mars is no longer a distant alien world, but a second home for humanity, a place where human ingenuity and determination have transformed a harsh and unforgiving environment into a thriving, self-sustaining outpost of civilization. Picture futuristic cities enclosed beneath transparent domes, bathed in the warm glow of artificial sunlight, where lush gardens flourish and children run and play under a pink Martian sky. This vision of a future forged on Mars is not merely a utopian fantasy. It's a goal that we can strive towards, a testament to the boundless potential of human ingenuity and our capacity for adaptation and innovation. The technologies required to establish a permanent human presence on Mars are within our grasp, and the challenges, while significant, are not insurmountable. The journey to Mars will be long and arduous, fraught with risks and setbacks, but the rewards, both tangible and intangible, will be immeasurable. By pushing the boundaries of exploration, by challenging ourselves to overcome seemingly insurmountable obstacles, we will not only unlock the secrets of the Red Planet, but we will also ignite the imaginations of generations to come, inspiring them to dream big, to reach for the stars, and to continue humanity's grand adventure among the cosmos. As we've journeyed across the vast expanse of space and time, exploring the rugged beauty and the scientific wonders of Mars, we've encountered more than just a celestial neighbor. Mars, the red planet, has served as a mirror, reflecting back at us our own human aspirations, our relentless curiosity, and our unyielding determination to push the boundaries of what's possible. For millennia, Mars has captivated our imaginations, inspiring myths and legends and fueling our dreams of reaching beyond our terrestrial cradle. It has served as a blank canvas upon which we've projected our hopes and fears, our visions of extraterrestrial life, and our aspirations for a future among the stars. Now, on the cusp of sending humans to Mars, this once distant and enigmatic world has transformed into a tangible destination, a testing ground for our technological prowess and a crucible for the human spirit. The challenges of reaching Mars, of establishing a foothold on its alien surface, and of unlocking its secrets are daunting, to be sure. But they are challenges that we, as a species, are uniquely equipped to embrace. The pursuit of knowledge, the thirst for exploration, and the drive to push the boundaries of what's possible are woven into the very fabric of our being. They are the forces that have propelled us from the savannas of Africa to the surface of the moon, and they are the forces that will ultimately carry us to the shores of Mars and beyond. The journey to Mars will be the ultimate test of human ingenuity, resilience, and our capacity for collaboration. It will require us to pool our collective knowledge, to overcome technological hurdles, and to confront the unknown with courage and determination. But the rewards of such an endeavor, both tangible and intangible, will be immeasurable. By setting foot on Mars, we will not only expand our scientific understanding of the red planet and its potential for hosting life, but we will also unlock new frontiers of human potential. We will learn to adapt, to innovate, and to thrive in an environment vastly different from our own, pushing the boundaries of human ingenuity and forging a new chapter in our species' grand narrative. The journey to Mars will be a journey of transformation, not just for the brave souls who make the trip, but for all of humanity. It will challenge our preconceived notions of what's possible, ignite the imaginations of generations to come, and inspire us to strive for a future where the boundaries of our world extend far beyond the confines of our pale blue dot. As we stand on the precipice of this next giant leap for humankind, let us embrace the challenges that lie ahead with courage and determination, knowing that the journey to Mars is not just about reaching a distant planet. It's about pushing the boundaries of human potential and inspiring a future filled with wonder, discovery, and the boundless possibilities that await us among the stars.